Continuing on with this problem, which I said was a much more difficult problem, we want to figure out where things are, where this second derivative is equal to 0, because our ultimate goal is to find those points of inflection and where our concavity changes. So when I put 0 in, I'm going to take note that I've got places where it does not exist here at -3. So it does not exist, the derivative does not exist, because up here, remember, it was an endpoint. So of course it does not exist there. But I'm really just concerned where it's going to equal 0. So that would be on the top of this fraction right here only. So I'm going to just take that part and set it equal to 0. And I'll find out that the x value that would give me a 0 would be -4. Well, -4 is not even in my domain, so there are no points of inflection. So this graph simply is concave up or concave down. Remember, it only goes from -3 to infinity, so I can only test this one interval. So what we're going to do is we're going to look at the second derivative, and we're going to try one of those numbers. I'm going to pick 0 because 0 is the easiest thing to work with. When I plug in 0 in for my second derivative, what kind of concavity do we have, positive or negative? Well, this would give me positive over a positive over divided by a positive. I don't even care what the value is, I just know it's positive. So it's going to be concave up from -3 to infinity. And that's the end of that problem. Remember, that is part of your assignment, so you can make sure and write that into your assignment. The next thing we're going to start to talk about is the second derivative test. And the second derivative test is a quick way to test whether it's a max or a min. So if you find your first derivative and you see that your second derivative is negative, then you know it has a local max. If you have your first derivative, your critical number, and you test that critical number into your second derivative and you find out it's positive, then it has a local min. It's easier to kind of see this in a problem. So what we're going to do is take and find the second derivative. So let's see here. The first derivative ends up being -2 x minus 5, and I'm going to then, and that's it, distribute this, so I get -2 x plus 10. Well, my second derivative just happens to be just plain old -2. This problem makes life really easy because I can then test what my critical number was. I need to go back up here and find my critical number to find out where there is relative extrema. So where is my first derivative equal to 0? Well, it's simply just at x equals 5. You're going to test that in here. Well, there's nowhere to even plug that into. It just means that it's concave down everywhere. It's concave down everywhere. So I need to say that at 5, it's concave down. So this would happen to be a max by the second derivative test. The next thing we're going to look at is this problem. What I'm going to do is I'm going to find the first derivative, and I will get my critical numbers. So I end up finding out it to be critical numbers when this is factored. This is x minus 3 times x minus 3. So my only critical number is at x equals 3. I want to know if it's a max or a min. So I'm going to use the second derivative to test that. I could test it with intervals too, just like we did in section 3.3. But I'm going to use my second derivative test. It's a little bit faster because my second derivative is very easy to find. When I plug in 3 into my second derivative, I end up finding out, well, I get 0. So it's neither concave up or concave down, and I can't use my second derivative test. So while I thought this was going to be easier, it ends up being a little bit more work. So the second derivative test does not apply because I didn't get a positive or negative value. If I would have, I could have just been done. But I need to use my first derivative test, which says I'm going to plug in 2 for this derivative here, and I'll find out that I end up getting positive on both sides when I test those. So what this means is that it's increasing everywhere, and it has no relative extrema. Please ask me to do another type of this in class.